Good morning, my dear students. Let us go for the next and last session of electrochemistry. So, objectives of today's lesson, that is, after completing of this period, you will be learning about the following topics. What is battery? What are the types of batteries? What is a Leclanche cell? What is a nickel cadmium cell? What is a fuel cell? And also we are going to study about the example of fuel cell, that is hydrogen oxygen cell. So these are the topics which we are going to deal with today. Recap. So what we have studied, let us, before starting the today's topics, let us revise the topics which we have studied in the last classes, is it not? First of all, what is electrolysis? What do you mean by electrolysis? Electrolysis is the process of decomposition of an electrolyte when electricity is passed into that solution. So that is decomposition of electrolyte brought by the electricity. That is where electrical energy is converted into chemical energy. What is an electrolytic cell? A cell in which electrolysis takes place, or a device in which electrical energy is converted into chemical energy. What is a galvanic cell? So it is opposite to electrolytic cell. What happens in galvanic cell? Galvanic cell produces electricity. It is the source of electricity. How it produces electricity? There are some reactions. There are some chemical reactions taking place in it, due to which electricity is produced. So what is that? It is a device which converts a chemical reaction, chemical energy into electrical energy. How? That is some oxidation reduction, which we are calling as redox reaction, takes place in it, due to which there will be a flow of electric current from one point to another point, due to which electricity is produced. So electrolytic cell is a device which converts electrical energy to chemical energy, whereas galvanic cell is a device which converts chemical energy to electrical energy. All these things we have studied in the last classes itself, is it not? What is standard electrode potential? That is, in a galvanic cell you find two electrodes. That is, one electrode loses electrons, undergoes oxidation, another electrode gains electron, undergoes reduction. So what is the thing that is making one electrode to lose an electrode and another to gain electrode? That is the tendency of those electrodes. The tendency of an electrode either to lose electrons or gain electrode, it is called as electrode potential. That is the tendency of an electrode either to undergo oxidation or reduction. So the electrode potential is also called as oxidation potential or reduction potential. When this electrode potential is recorded under standard condition in comparison to standard hydrogen electrode. What are the standard condition? That is when it is connected to standard hydrogen electrode, and when it is recorded at 25 degrees centigrade, and when it is in contact with 1 molar concentration of its electrolyte, then it is called as standard electrode potential. So standard electrode potential is a value that is possessed by each electrode. And what is electrochemical series? It is a series, or it is a table, or it is a list of electrodes where the electrodes are arranged in the increasing order of their electrode potential. That is, the least electrode potentials are at the top and the higher electrode potentials are at the bottom. That is called as electrochemical series. So that is, electrodes at the top, they are having least electrode potentials, means they have least reduction potential, that means they easily undergo oxidation, whereas the one which are at the bottom, they undergo reduction. So when you compare any two metals, the metal which is at the top in the electrochemicals, it acts as anode, the one which is below it acts as anode due to its oxidation reduction properties. What is EMF? The difference in the standard electrode potentials of two electrodes, that is taken as EMF. What is this EMF? Electromotive force. That is the force which drives the electrons from one electrode to another electrode. So, from where to where electrons go? That is, electrons go to from a lower electrode potential electrode to higher electrode potential electrode. That is from oxidation electrode to reduction electrode. From anode, that is negative electrode, to cathode, positive electrode. So that is the force or the potential that is driving the electrons from anode to cathode, or the force that is driving the current from cathode to anode, that is called as electromotive force. How you get the electromotive force? It is the difference in the electrode potentials. So how do you calculate the EMF of a cell? That is, you know that is the one which is losing have low electrode potential. The electrode which is gaining electrons means it is having higher electrode potentials. If you subtract the EMF of anode from the EMF of cathode, you will get the difference. That difference gives the EMF of the cell. More the difference, more the EMF means more the current. Are you able to follow? So that is about the EMF of a cell. These are the things which we have studied. Now let us know what is a battery. So the definition of battery. It is a group of galvanic cells designed to convert the chemical energy into electrical energy by spontaneous redox reactions. So battery is nothing but it is a group of galvanic cells which is designed to produce electricity by the redox reactions. It is not the single galvanic cell, a group of galvanic cells arranged in a series. So that more electrical energy is produced. That is called as a battery. Because if you take the case of galvanic, what you call Daniel set, it just produces 1.1 volts of it. That is not sufficient to run a what you call any electric device. So 2 volts or 3 volts is enough, is it not? So that's why there 2 or 3 galvanic cells are connected in a row to form a battery. Battery is nothing but that is a big form of a galvanic cell, because it consists not more than one galvanic cells arranged in a row. So battery is the direct source of electric current, and it supplies a constant voltage of current. Batteries are two types. We are going to study two types of batteries: primary battery, secondary battery. So are you able to follow? Primary battery and secondary battery. Let us know about primary battery. What do you mean by primary battery? The batteries which produce anything, battery is the one which produces electricity. But after using over a period of time, it becomes dead. It cannot be recharged and it cannot be reused. If then it cannot be recharged, then it cannot be reused, is it not? And just we throw it outside. Such batteries are called primary batteries. That is, batteries which can be used only once, which cannot be used again, because they cannot be recharged, they cannot be reused. Such batteries are called primary batteries. For example, nowadays, that is, if you say the batteries, what comes suddenly into your mind? That is batteries which we use in our transistors, clocks, or even what you call torch lights, all these batteries. These are all called dry cells. That is there. That is the whatever the electricity is produced for some time. After that, the battery becomes dead. That means it gets exhausted. The chemical reactions are over. You cannot reverse the chemical reaction. That's why you cannot recharge it. Then its lifetime is over. You have to dispose it off. That is batteries which can be used for a time for a specific time and then dispose such batteries because they are said to be dead batteries. Such batteries are called as primary batteries. So generally, the electrode reactions are irreversible. That is, the redox reactions, they are irreversible. They cannot be reverted back. So examples of such primary batteries are the normal batteries which we use in our transistors, radios, or what you call electronic toys are able to follow. Secondary batteries. The batteries in which original reactants are regenerated by passing direct current from external source and reused again are called secondary batteries. That is, even the secondary batteries, when you use over a period of time, they get discharged. But the advantage of secondary batteries is that is we can pass direct current from an external source. Let us take it from plug point or any other point that is a direct source of electricity. We can, if you pass electricity, what happens? The redox reaction reverse, that is oxidation reaction becomes reduction reaction and reduction reaction becomes right. That is, you will get the original reactant so that again the battery can be reused. That means here the basic difference of primary batteries and secondary batteries. Primary batteries, there is that is the reaction takes place only once. They cannot be reversed. But here one, that is after the discharging, that is you can send the electricity and again you get the original reactants by regeneration. So they can be recharged and reused. Such batteries are called secondary batteries. Here the electrode reactions are reversible. So because here you can store the electrical energy by converted into chemical energy. Whenever you use the chemical and whenever you need, you can convert the chemical energy to electrical energy. Once it is discharged, again you can convert, that is you pass the electrical energy, it is again stored into electrical energy. So that's why these cells are called, these batteries are called storage cells. So examples are lead storage battery or lead acid battery or lead acid cell, or and also nickel cadmium cell. Let's study about the dry cell or Leclanche cell. It is a primary cell without fluid. There are no fluids. It contains a zinc container. It is just a container, a zinc container. The container itself acts as anode. And it contains an electrolyte which is a mixture of ammonium chloride, zinc chloride and manganese dioxide, to which starch is added to make it thick paste like. So this mixture is not in the fluid way, it is in the form of a thick paste due to the addition of starch with it. So that is the electrolyte. What is the anode? The zinc container acts as anode, and the electrolyte is the mixture of ammonium chloride, zinc chloride and manganese dioxide mixed with starch, which looks in a semi-gel state. And at the center of this what you call zinc container, there is a carbon rod, graphite rod immersed, that acts as cathode. So you see here The red colored is what is that? The zinc can, or what you call zinc container, that acts as anode. So this container acts as what you call zinc anode. The middle one is called as graphite rod, that is acts as cathode. In between these two things, what is the paste? What is there? Paste of manganese zinc chloride and ammonium chloride along with what you call carbon powder or starch to bake it in, to put it in gel state, or what you call paste. So this is the construction of what you call dry cell. So here, it is covered with insulator on one side. Only this part is exposed, is it not? So only this part is exposed. This is plus part, this is minus part. Okay, what is happening here? Let us see. So during the working of cell, the zinc anode, that is the zinc container, contains zinc atoms. They convert into zinc ion, Zn2 plus ion. Each zinc atom converting into Zn2 plus ions releases 2 electrons, and these electrons are consumed at cathode. At cathode, manganese, MnO2 is there. No, manganese reduces to MnO2 reduced to MnOOH from plus 4 to plus 3 state. That is, the electrolyte, it is loose, that is, it is gaining electron and forming plus 4 to plus 3, whereas zinc is releasing 2 electron, that is 2 MnO2 is becoming MnOOH, manganese oxyhydroxide. The EMF of the cell is 1.5 volts. So I think you have seen that 1.5 dry volt cells. What are the reactions that are taking place? At anode, the zinc is losing electron to form Zn2 plus 2 electron. What do you call this reaction? It is the oxidation. At cathode, normally what reaction takes place at cathode? It is a reduction. Which one is undergoing reduction? MnO2 in presence of ammonia. It is taking electron to form Mn2O3, 2NH3 plus H2O. So, total cell reaction can be written as Zn plus 2NH4 plus 2MnO2, Zn plus 2Mn2O3 plus 2NH3 plus H2O. So what is the E cell? E cathode minus E in anode. 0.74 minus of minus 0.76. So it becomes 0.74 plus 0.76. So what is its EMF? E cell is equal to 1.5 volts. The produced NH3 plus ions combine with Zn2 plus ions to form zinc ammonate complex. So where it is used? Generally, in olden days, people used to have transistors, that is small radios. That is, in transistors we use it, in radios, big radios we use it, clocks, and even the hearing aids. The next one is a secondary cell, that is nickel cadmium battery. It is a rechargeable battery. In this, anode is cadmium metal, cathode is nickel oxide. The potassium hydroxide is electrolyte. It is also known as alkaline storage battery. So nickel cadmium battery. So are you able to see here the diagram? So you have cadmium anode in the middle, nickel cathode outside, is it not? Both are separated by a separated. They are not in contact with each other. What happens? Let us see. So during discharging, that is, here you have two sets of reaction. That is, first discharging. That is when it is using as galvanic cell. That is when it is producing electricity. So when discharging, what happens? When nickel battery operates as galvanic cell, the CD oxidizes to CD plus 2. CD becomes CD plus 2 means it is undergoing oxidation, and which combines with OH minus to form CdOH. Where is this OH? And that is KOH is there, no? So here at cathode, NiO2 is there, nickel dioxide is there. NiO2 means it is plus 4. NiO2 means by minus 2, minus 2, minus 4. Therefore, Ni is plus 4. So it reduces to plus 2 by taking 2 electrons given by cadmium, which combines with the OH minus ions. So what you are able to see here? So CD metal atoms, first they form CD plus 2 and combine with the OH to form CdOH. NiOH2, it is also forming ultimately it is also forming NiOH twice. Reactions during discharging as galvanic cells. KOH is forming 2OH at anode. CD is forming cadmium hydroxide. At cathode, nickel hydroxide is forming NiOH twice. The total Cl reaction is like this. So what is happening? That is, at anode, cadmium hydroxide, at cathode, nickel hydroxide is formed. So here, that is, after this one, that is the cell is completely discharged. The EMF of the cell is 1.2 volts. Reactions during recharging. The products formed during discharging, that is NiOH and CdOH, stick to the surface. When the current is passed, the electrode reactions get reversed at anode. So again NiOH2 becomes NiOH, nickel oxyhydroxide. At cathode, CdOH twice forms CD. Again you are getting CD. The net reaction is like this. So this is recharging reaction. Again it is getting recharged. Again you can discharge it. You can recharge. So that's why it is a storage cell. Are you able to follow? What are the applications of? So nickel cadmium cells are used in portable power tools and electronic devices. It is also used in flashlights, emergency lights. It is also used in wireless telephones, UPS, uninterrupted power supply systems, and also computers. So that is about the nickel cadmium battery. Nickel cadmium battery is a storage battery. So what is the another battery apart from the nickel cadmium battery? Lead acid cell. That is a big one. We'll read separately about that battery. Are you able to follow? So we have seen the one primary battery and one secondary. What is the primary battery we have studied? Leclanche cell or dry cell. What is the secondary battery we have studied? It is a nickel cadmium battery. And we are going to study what you call lead acid cell in the separate session. Okay. So now I'll go to another type of battery, that is called as fuel cell. What is this fuel cell? Let us see. A fuel cell is a device that converts chemical energy of hydrogen fuel with oxygen directly into electrical energy. A device that converts chemical energy of a fuel into electrical energy by electrochemical reaction is called fuel cell. So what you should So fuel cell is a device that converts chemical energy of a fuel into electrical energy by normal cell, that is electrochemical reaction, that is redox reaction, that is called as fuel cell. In this fuel does not undergo combustion. Generally, how the fuels give energy? By combustion, that is by burning in the presence of oxygen. But that is not happening here. What is happening here? That is, here oxidation and reduction are taking place, due to which it is producing the electrical energy. So when you subject the fuel to combustion, it produces the heat energy. Is it not? That heat energy may be converted into electrical energy. But here in this case, by oxidation, by redox reaction, you are directly converting the fuel into electrical energy. Example is a hydrogen oxygen fuel cell. This cell consists of porous carbon electrodes as anode and cathode. So here porous carbon electrodes, they act as anode and cathode. Small amount of powdered platinum and palladium or silver, which acts as catalyst, is added to electrodes. Why we are using platinum, palladium or silver? Because hydrogen can be absorbed by platinum, palladium or silver. They act as catalyst, they speed up the reaction. At the center we are taking the potassium hydroxide or sodium hydroxide, like any strong alkali, as electrolyte, which is placed between the electrolyte. Two electrodes are connected to voltmeter. So are you able to see here? So at the center, what is there? NaOH RKOH, a strong electrolyte. Here minus, here it is plus. So what is happening here? H2, it is by losing electrons. Hydrogen, it is undergoing oxidation, losing 2 electrons. And here, that is these H plus ions. So these 2 H plus ions travel to this side, and these H plus ions taking electrons combine with oxygen to form H2O. So here, that is, electrons are traveling from this to this. So here what is happening? The oxidation is taking place. Same hydrogen ions, they are undergoing reduction. Is it not? So here 2H plus ions traveling here and electrons are traveling here. So here you are passing oxygen gas, hydrogen gas. So here hydrogen gas is undergoing oxidation. The same H plus ions, they are undergoing reduction here. And electrons are passed from here. And H plus ions travel to this one, because KOH ions, they are taken, pick up by here, and they are releasing here like this, is it not? So what you are getting here, that is water as a byproduct. Pure water you will get it. So let us see the reactions. Working of H2O2 fuel cell. Hydrogen gas is passed through anode compartment and oxygen is passed through cathode compartment at 50 atmospheric pressure. In the cell, H2 is oxidized and oxygen is reduced at their respective electrode. The EMF of the cell is, are able to see here. So here hydrogen electrode, it is undergoing oxidation and oxygen is undergoing reduction, due to which electricity is produced. And so electrolyte is KOH, it is K plus OH minus ions. At anode, what is happening? H2 is taking 4OH minus to form 4H2O plus 4 electrons. At cathode, O2 plus 2H2O. This is oxygen is undergoing reduction by taking water in presence of 4 electron, it is forming 4H. So here you see here the OH minus ions that are utilized here by the hydrogen for oxidation, they are again regained here in the reduction. So that is KOH concentration remains the same, is it not? So it is losing OH minus at anode and it is again gaining the OH minus ions. But in the process, what is happening? Anode is losing 4 electrons which are traveling to cathode. This what you call, this travel of electron from anode to cathode results in the production of electrical energy which passes from cathode to anode. What is the byproduct that is formed in this case? H2O, water, pure water is formed. So 4H2O here, 2H2O molecules are utilized. So what is the balance? 2H2O. Net reaction 2H2 plus O2 gives 2H2O. So fuel cells are highly efficient than thermal production of electricity. Generally, if you want to get the fuel, let us take from coal, hydrogen. If you burn the hydrogen in presence of oxygen, it produces a what you call thermal energy. That thermal energy has to be converted into electrical energy, but that is not efficient. The fuel cell is directly giving the electrical energy, so it is higher efficient than thermal production of electricity. It is free from noise, air or water pollution. Generally, when you use the fuels in the combustion of fuels, you will get so many pollutants. Is it not? There is no noise because even combustion also produces noise. There is no air pollution. There is no water pollution. Because what is the byproduct you are getting in this fuel cell? Only water, that too pure water. So it runs continuously as long as fuel is supplied. As long as you are supplying the H2 and O2, it runs continuously. Easy to maintain. The produced water can be used as distilled water. So that's why these cells are used in spacecrafts, submarines and military vehicles. So that is spacecraft, submarines and military vehicles, they need more oxygen. That is oxygen supply is there. You don't need to carry the fuel. Oxygen and hydrogen is directly available from the air. Even the spacecrafts, submarines. In submarines also. So what is the advantage you will get? You can also use the water that is formed as a byproduct. So that is about the three types of cells which I have studied. What are the three types of cells? The primary cell, that is Leclanche cell, the secondary cell, nickel cadmium cell, and the fuel cell, H2O2 cell. Are able to follow? So what we have studied today, what is a battery? It is a device which produces electricity, which is made up of a series of electrochemical cells, not a single electrochemical cell, or series of galvanic cells. So you know the batteries are two types: primary batteries, secondary battery. Primary battery is non-chargeable, non-rechargeable battery. Secondary battery is rechargeable battery. So what is the example for primary battery? Leclanche cell, a dry cell which we use in our daily life, in transistors, radios, clocks, torch lights, etc. And what is the example for secondary cell? Lead acid cell or nickel cadmium cell. Today we have studied the nickel cadmium cell. And fuel cell produces electricity without combustion of fuel. So the fuel cell is a one which produces electricity due to the oxidation reduction that takes place in hydrogen and oxygen. So such example we have seen, that is hydrogen oxygen fuel cell. Dry cell is an example of electrolytic cell, fuel cell, primary cell or secondary cell. What is the correct answer? Dry cell or Leclanche cell? We have seen. That is, dry cell is an example of primary cell. So the C is the correct option. A storage battery acts as electrolytic cell, galvanic cell, both, or fuel cell. You know that storage cell itself means it stores the electrical energy as chemical energy. That means whenever you discharge, it acts as galvanic cell. Whenever you charge, it acts as electrolytic cell. So that's why it acts both as electrolytic cell and galvanic cell. So the correct option is C, both. An example for fuel cell: Leclanche cell, nickel cadmium cell, lead acid cell, H2O2 cell. So Leclanche cell is an example of primary cell. Nickel cadmium cell is secondary cell. Lead acid cell is also secondary cell. So what is the correct option? The third one, H2O2 cell, that is the correct option. So what are the frequently asked questions? Explain the construction and working of dry cells. Do you remember the dry cell? Or what is used in, what is the construction of dry cell? It contains zinc container, acts as an anode, in which manganese dioxide, ammonium chloride, and what else? Zinc chloride, that is ammonium chloride and starch, MnO2, manganese dioxide, ammonium chloride is used as electrolyte, and at the center you will have a carbon graphite. So what is happening? Zinc is undergoing oxidation and the manganese is undergoing reduction. Explain the construction and working of lead acid accumulator. Explain the construction and working of nickel cadmium battery. These two are secondary cell, whereas the dry cell is the primary cell. Explain the construction and working of H2O2 cell. So these are the frequently asked questions. So with this we have completed the batteries. So I think we have completed even the all the topics in electrochemistry. So we'll start with the next chapter in the next session. Shall we stop? Thank you.